All right, y'all. Welcome back to our last section, or one of our last sections. Today, we are going to talk about complex numbers. Okay. Now, you all did this back in Algebra 2. All right. But we'll just see what you remember. I know you did in Algebra 2 because I teach Algebra 2 as well. All right. So, hopefully, you all will remember this and it'll be relatively easy. Okay. Now, complex numbers, all right, are a real number and an imaginary part put together. All right. That's what makes it complex. So, an imaginary number I is defined as the number whose square root is -1. Remember, whenever we square root a negative number, we have to put I on the end. All right, because a negative square root is I. All right, that's how we know it was negative. Okay. The other key thing that you need to remember is whenever you see I squared, that is always going to be -1. All right, that will be really, really important here in just a little bit. So I squared is -1. Okay. Like I just said a minute ago, complex numbers are imaginary and real numbers combined. They're written in the form a plus bi, where a and b are real numbers. So this a part is what we call the real part. The b part is what we call the imaginary part. It's easy to tell them apart because the imaginary part has an I, right? The real part does not. Okay, so that's what makes up a complex number. You have a real part and an imaginary part together in one. All right, so let's start with just a couple of examples. Okay, just keep it as basic as we can. So this says the square root of -27. Now that's not a perfect square, right? But I could split it up into something that is a perfect square. For example, -27 is the same thing as -9 times 3, right? So the square root of -27 is -9 times 3. Now we all probably know the square root of 9, right? The square root of 9 is 3. But since that 9 is negative, right? Since the 9 is negative, we have to have an I in front. So the answer to this is actually 3I, and then that 3 stays on the inside. Okay, so it's just like we would do before. If it was just square root of +27, right, I would split that up into 9 times 3. Square root of 9 is 3. So if it was +27, I would have 3 square root of 3. But since it's -27, I have 3I square root of 3, right? So nothing's really changed, right? We're just adding an I now because it was negative, okay? That I tells us the original problem was negative, all right? We would do the same thing over here. We would do the exact same thing. So square root of 2, there's nothing, square root of -2, there's nothing I can do, but it's negative, right? So I could pull an I out and keep the 2 right where it was. Okay, now 8, I could simplify a little bit. I could turn that into -4 times 2. So the first one's not going to change. But the square root of -4 is 2I square root of 2. Right? Because the square root of 4 is 2, but since it's negative, I have to put an I in front. And now you should hopefully notice that these two have the same radicand, right? They have the same stuff under the radical. So therefore, they're like terms. So I'm just going to add what's in front. 1I plus 2I is 3I, and the square root of 2 would stay the same. Okay, so it's not any different. The only difference is now we're adding an I in front. All right? So we kind of just did this next part right here. Add and subtract. All we need to do is combine like terms. Think of I like an X. Think of it like a variable. All right? So if I were combining these, I have 5 plus -2. Neither one of those has a variable. 5 plus -2 is 3. Then I have 7I plus 6I. 7 plus 6 is 13I, and we're done. Right? So it's exactly like if you had a variable. Nothing's changed. Nothing different about it. Okay? The same exact thing when you subtract. Just now you minus instead of add, right? So 8 minus 2. 8 minus 2 is 6. And then with the i's, you have 3I minus 4I. Right? Those are like terms. They have the same variable. 3 minus 4 is just -1. So I'm going to put minus I. You can put 1I if you would like. Doesn't really matter, but we don't have to put the 1. Okay, so adding or subtracting hopefully is pretty easy. Okay, pretty easy. All right, now we're going to look at what you do when you multiply. All right, we got a couple of problems left here. So we're going to look at this example right here. Okay, when you multiply, okay, you're going to multiply the same way you've always multiplied. You're going to distribute. Okay, the only thing that you need to remember is that I squared becomes negative 1. Remember at the beginning, I made a box around the I squared equals negative 1. All right? So let's just multiply these. We're going to do this first one, number 5 right here. All right? So we distribute, just like always, or FOIL if you learned FOIL. 4 times negative 3 is negative 12. 4 times 5 is 20i. Then we do the same thing with the negative 9i. Negative 9i times negative 3 is positive 27i. Negative 9i times positive 5i is minus 45i squared. So nothing new, right? Just treat I like an X or a Y or an A or a B, okay? Now, these two in the middle, you should notice, right, have the same variable. So they are like terms. So I'm going to put them together. So that would give me 47i. The negative 12 hasn't changed. But over here, you notice that I have an I squared right there, okay? And that I squared, I need to change to negative 1. Because I squared is always negative 1. So this is going to become negative 45 times negative 1. And then we're just going to simplify some more. So if we were to simplify this now, the negative 12 hasn't changed. The 47i hasn't changed. But negative 45 times negative 1 is positive 45. And then there's one last step. I have a negative 12 and I have a 45. Those are like terms. Negative 12 plus 45 is 33 plus 47i. So it's exactly like if it was an x. The only difference is that I squared turned into negative 1. Okay? I squared turned into negative 1. All right, so what's the point of complex numbers? What's the point of imaginary numbers? The point of them is that we are now able to solve quadratic functions, quadratic equations, quadratics in general, that don't necessarily cross the x-axis. Because normally when we solve quadratics, we're solving for the x-intercepts, right? But they don't always cross the x-intercepts, right? So therefore, we have to know how to solve it when it doesn't. So this is the last problem we are going to do. Complex solutions to quadratic equations. All right, so what we need to do is we need to solve this problem. And to do that, we are going to use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So we are going to use the quadratic formula. I told you I have to sing that song. Hopefully you've watched the 2 song videos that we had posted on Canvas because they're incredible, and you are so welcome for that. So we just have to pick out a, b, and c and plug them in. So let's do that. A is always in front of x squared. B is always in front of x. C is always the constant. All right? So I'm just going to plug in what I know. Negative b. So negative b is 2 plus or minus the square root. B squared. B is 2. 2 squared minus 4 times A is 3. C is 5. Divided by 2 times 3. All I did was plug in A, B, and C wherever they go. All right, now we're going to simplify. So this would be negative 2 plus or minus the square root. 2 squared, 4. Negative 4 times 3 is negative 12. Times 5 is negative 60. All over 6. So now I'm going to come down here so I have more room and keep solving. The negative 2 hasn't changed. 4 minus 60 is negative 56 all over 6. Hopefully y'all are with me. All right. So now negative 56 isn't a perfect square. So this goes back to what we did at the beginning, right? We need to think about a perfect square that will go into negative 56. Okay, is there something that will work? Is there some number that we could use that will go into that? And we have to think about it. We have to think about it. We have to think about it. If we do, hopefully we end up at negative 4 times what? Times what? Times what? Anybody got an idea? Anybody got an idea? Correct. 14. Negative 4 times 14 will get us negative 56. And then the 6 is still on the bottom. Okay. So now we just simplify. The negative 2 still isn't changing. That's never going to change. Not yet, anyway. Got a little ahead of myself here. Hold on. Just ignore that step. The negative 2 plus or minus. Now, the square root of negative 4. The square root of 4 is 2. But since it's negative, it is going to become 2i. Okay. And the 14 can't be split up anymore. So it stays the same. So here's where we're at. Negative 2 plus or minus 2i square root of 14 over 6. So since we have an I in this problem, that means graphing it wouldn't have helped us because it's not going to cross the x-axis. All right? There's one last step. All of these numbers in front or underneath of the square root, this negative 2, this 2, and this 6, all of those are even, right? Since all of those are even numbers, I could divide them all by 2. So if I did that, it would be negative 1 plus or minus. Negative 2 divided by 2 is negative 1. 2 divided by 2 is just 1, so plus or minus I. The 14 is not going to change. Over 6 divided by 2 is 3. So divide all of these by 2. There's my final answer, right? So kind of ugly, right? There's an I in the answer, which again is the point because it says you're going to have complex solutions, right? So we have an imaginary part and we have a real part in this answer, okay? So those are our notes for complex solutions. Y'all will have your Delta Math assignment. I appreciate y'all very much. If you have any questions, please reach out to me. I will be more than happy to go over it, okay? Thank you. Thank you.